Alright, 322, you mainly focus on the experiment, and it's fine, but I just want to make sure you caught some of the key things, and some of the stuff should have been in your lab report. So, with cancer, the skin cancer is caused by UV radiation causing thymine dimers. Remember, there's thymines and adenines. The thymines is just a T. And what it does is it causes this little kink in the DNA. So right here, when the UV causes these dimers here, it causes this little kink in the DNA, and then DNA can't be copied or used to make a protein. In the yeast, it can't be copied, and the yeast die. In us, what happens is if this happens in a tumor suppressor gene, the gene will not be able to make a protein, and then it can't stop the cells from dividing, and then you got cancer. Alright, so if a pyrimidine dimer happens or UV radiation does cause cancer, it's usually because it causes a fault in the DNA, which makes it stop producing the tumor suppressor protein, so it will continually divide. Alright, so that is a problem. In the mutant yeast, it just causes it to stop dividing. Now, normally we can walk outside every single day and not get skin cancer. And that's because we have enzymes that constantly check our DNA and look for these mutations. And then when they find this mutation, they can do two things. And it's not a big deal that you memorize these, but one, we can actually repair it and just cut those two apart and restore it back to the regular T's. Or we can again repair it, but this time we actually cut this section out and then fix it, replace it with a new section where that is right. Alright, so skin cancer happens when this enzyme, either because we're exposed to too much UV radiation, the enzyme just misses one of these mutations here, alright, in the tumor suppressor gene. And again, in the mutant didn't have these enzymes, and when we're talking about the yeast, it didn't have these enzymes to stop this. So, if we go to the yeast, so I already was talking a little bit about this, so the mutant yeast have faulty enzymes, they're mutated for those enzymes that repair the DNA. So if they can't repair the DNA, they all die. And the yeast dying is similar to cancer, not in the fact that they all die. Cancer cells grow tremendously, just the fact that it's showing that the UV radiation damaged the cells. Alright, and then the last one is to prevent cancer, we need to identify it. So there's basal, well, first let's look at the types of cancer here. There's basal / squamous. They're a little bit different, but just because they occur in different cells, but they're about the same thing. And then there's melanoma. Melanomas will metastasize or spread. So they go through metastasis, so they're more dangerous, whereas the basal and squamous usually don't spread very much. How do you identify it is you're looking for, so here, this bottom half of the tumor here, I mean not tumor, but mole, is different from this top half. The border here is irregular, and it's actually irregular on all these. The color is usually irregular. Alright, so we're just looking for irregularities. So you see how it's like a light tan here and then goes to dark black. Alright, so there's different tan. The diameter here is going to be bigger than 1/4 of an inch. I mean, so if it's bigger than that, we're going to be looking for cancer. And then if it changes. So that is what we're looking for to see if our mole might be cancerous. And that's pretty much all you need. And then, of course, the preventions, but you guys pretty much know how to prevent skin cancer, I would hope.